Okay, I'm going to give us one more look at a KSP problem with common ion effect associated with it. So we're going to work a problem with straight up KSP, and then we'll rework it in the presence of a common ion. So we're going to work calcium fluoride. Has a KSP of 3.4 times 10 to the minus 11. So first thing we're going to do, calculate the concentration of Ca2 plus in pure water with saturated CaF2. And then after this one, we're going to rework the problem in the presence of a common ion. So a concentration of Ca2 plus dissolved in pure water. So for CaF2 as our substance, calcium is X, fluoride is 2X from our subscripts, right? So our KSP is equal to the concentration of Ca2 plus times F1 minus squared. Has a numeric value of 3.4 times 10 to the minus 11. Plug in our algebra. So we have X and 2X quantity squared equals our KSP number. And then this becomes 4x cubed. We get a lot of 4x cubes when we work solubility problems. So x cubed is 4.3 times 10 to the minus 11th divided by 4. (1.075) times 10 to the minus 11th. X is the cube root of that number. Cube root of that number, I get 2.21 times 10 to the minus 4th. That's molar. And we check and make sure that X is the concentration of our substance we're looking for. We're looking for Ca2 plus. Calcium was X. So that one actually is our answer right there. So in a regular problem, regular KSP, without a common ion, 2.21 times 10 to the minus 4th molar calcium ion from saturated calcium fluoride. Now we're going to rework this one. So part B. Rework it dissolved in 0.250 molar NaF. So fluoride ion now is our common ion. We have 0.25 molar fluoride present. Now from our ice table when we set it up, we ended up with a concentration and an X term along with it, and we dropped the X. We're always going to do that. If we compare this molarity with this KSP from our original problem, big difference between those two. So the concentration of fluoride ion in our solution is just 0.25 molar. Now, if you want to write out the ice table and do all that stuff, great. But you can save yourself some time if you realize that KSP, which is Ca2 plus and F minus squared, having a value of 3.4 times 10 to the minus 11th, can be written as X and 0.250 squared. And then we just rearrange and solve for X. X is 3.4 times 10 to the minus 11th divided by 0.250 squared. That has a numeric value of 8.5 times 10 to the minus 12. That's molar. It's X. X was and still is our concentration of Ca2 plus. So by adding a 1/4 molar fluoride ion to the solution, we go from 10 to the minus 4th molar calcium to 10 to the minus 12th molar calcium. A factor of 10 to the 8th, 10 million times difference between the two. And that's because of the presence of fluoride, which is also squared. So any fluoride that's present, the fact that it gets squared in the KSP calculation magnifies its effect. So any additional fluoride ion that we put in from 0 on up greatly decreases the calcium ion concentration. And that works for all substances. If you add one of the ions, you decrease its solubility accordingly. Okay? Thanks, guys.